Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to understand equivalence and equivalent expressions, how to maintain balanced equations even under unconventional operations, how to understand solutions and solution sets through mathematical inference, to make sense of word problems and be able to set up word problems into equations, to examine word problems and determine how their parts relate to quantities, to understand and or statements of inequalities, to graph all kinds of inequalities on the real number line, to solve systems of equations and determine the number of solutions, to mentally visualize the graphs of functions to understand their solutions, to recognize patterns in a round-robin style tournament in order to count the total number of games played, to use repeated reasoning to expand the tournament to include more teams, to relate word problems to probability functions, to recognize the difference between fixed and varying quantities within various scenarios, to recognize and state the relationship between the fixed and varying quantities, to recognize independent and dependent variables and relate them back to your understanding of fixed and varying quantities, to recognize the proper domain and range of various scenarios, to recognize the various mappings that can occur between domain and range, and to relate graphs, descriptions, and function equations to one another. How are we learning it? Through the reasoning about statements review notes and the reasoning about statements review assignment, as well as the reasoning with relationships review notes and the reasoning with relationships review assignment. When can we use this information? To complete daily tasks while maintaining balance, finding equivalent solutions to problems, to analyze how many solutions there are to any given problem in life, to sort through positive, negative, and neutral outcomes when deciding on a proper course of action, to apply mathematics and mathematical operations to real-world scenarios, to determine which scores you can receive on your final exam that will allow you to pass the course, to find economic solutions to financial problems, such as income versus expenses and supply versus demand, to determine how to run a successful company by utilizing the principles of supply and demand and production costs, to set up tournaments for your future children's sporting events, to predict the outcomes of events at work and in your personal life, to examine the variables that need to be accounted for when beginning a project, such as completing a big project for one of your classes, to recognize all the possible outcomes of various scenarios, such as the potential outcomes that would allow your favorite team to make the playoffs, and to connect and group information together when the information is the same but represented differently. How do you know you learned it? By getting a score of 4 on the reasoning about statements review assignment and a 4 on the reasoning with relationships review assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the reasoning about statements review notes, and then I'll give you time to complete the reasoning about statements review assignment. Once you've completed your assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to complete the reasoning with relationships review assignment and any incomplete assignments that you may have. Let's take a look now at the reasoning about statements review notes. The notes begin with the learning goals and success criteria. Think of equivalence as being a state of being alike in value. So we have different rocks, and notice they're all different sizes here, but their weights balance out, so that's what we need to do. So if we take one rock off, we need to make sure we do it to the other side as well and keep everything balanced. So let's look at a simple equation here. So we're given 3x minus 4 is equal to 5. Well, we all have our ideas of how to solve this, and most of us would just get to work right away. We'd add the 4 to both sides and then divide by 3. So let's go ahead and do that. So we add by 4 on both sides, and we're left with 3x is equal to 5 plus 4, which is 9. Then we recognize that 3 times x, to undo that, we're going to go ahead and divide it. So we divide both sides by 3, we get x is equal to 3. Easy enough, that's what we all would probably do. So to make sure that we maintain balance, we perform the same operation with the same values on both sides of the equal sign. Okay, easy enough. Now what if I told you to do something different? What if I said add 6 to both sides? That doesn't change anything, right? We're still keeping the equation the same, so we have 3x minus 4 is equal to 5. So I add 6 to both sides. and I get 3x minus 4 plus 6 is equal to 5 plus 6. So I combine like terms, so I get negative 4 plus 6 is positive 2, and 5 plus 6 is 11. So I get 3x plus 2 is equal to 11. Remember that the solution was supposed to be x equals 3, so we want to see if that still holds even after I do this operation. So then I plug in 3. I get 3 times 3 is 9, plus 2 is 11, which is the same. So the solution is exactly the same even though we added 6 to both sides. So as long as I stayed balanced, the equation stayed the same and the answer stayed the same. Now the question is, will this hold true for all operations and values? So is there anything I can do to both sides that will change this and make the answer different? So let's look at 3x minus 4 equals 5, so we have the same equation, and we're going to multiply both sides by 0. So when I do that, I get 0 times 3x minus 4 is equal to 0 times 5. Remember that the solution was x equals 3. Well, here I end up with 0 equals 0, which eliminated my x altogether. So now it does not hold up. So there are infinitely many solutions because 0 equals 0. So therefore, x equals 3 is not necessarily a solution. Now, undoing it. So it says if you can undo your work, meaning work backwards, and get back to the original solution, then the solutions are the same for the given operation. So remember, the solution was x equals 3. So we would state that from step 2 to 3, we multiplied some number by 0 and got 0. That unknown number could be any number, right? So it doesn't matter. Let's look at the other example we had. So on the previous one, we couldn't undo the work because the 0 screwed everything up. It made it so that any value could be in there for x and it would still be true, instead of just being 3 as our answer. So let's look at this one. We have 3x minus 4 is equal to 5, and 3x minus 4 plus 6 is equal to 5 plus 6. So first, remember that the solution was x equals 3. So we're going to try to work backwards. So if we work backwards, we would state that from step 2 to 3, right, from here we added 6 and got 11, and 6 to a number and got 3x plus 2. We can see that we would have then started with 3x minus 4 is equal to 5. So if we were to undo that step of adding 6, then we would end up with this, and therefore our solution would still be x equals 3. So if we were to take this and subtract 6 from both sides, basically, would we end up with the same thing? And in this case, we would. Factoring review. Let's look at method 1 of factoring. So we have 3x minus 6, and we should notice that there's a common factor there, which is 3, so we can factor that out. So this becomes 3 times x minus 2. Same thing here. We have 2x minus 4 is equal to negative 18. I can factor this, so I can take a negative 2 out of each. So this is negative 2 times x plus 2 is equal to negative 2 times 9. So that's method 1. Method 2 is difference of squares. Remember, difference of squares says that if I have two perfect squares and their subtraction, I can take the square root of each of them and make it a plus b times a minus b. So in this case, I look at this 9x squared minus 16. Well, 9x squared is really 3x squared, and 16 is really 4 squared. So I can rewrite that as 3x plus 4 times 3x minus 4. So it follows this pattern here. Same thing here. Now I have x squared plus 2x plus 1. And in reality, this is really a perfect square. So this is really x plus 1 squared, because it follows this form. A squared plus 2ab plus b squared, and that goes to a plus b squared. So what I should notice is I have a squared here. I have b squared. These are both perfect squares. And in the middle is double the product of a and b. So this is 1 times 1 is 1 times 2 is 2, which is what we end up here. So this is method 2. Method 3 uses the x method. So we have x squared plus 4x minus 5. Well, we put minus 5 up top and 4 in the bottom. We need two numbers that multiply to get negative 5 and subtract to get 4. Well, I should recognize that that's 5 and negative 1. So this becomes x plus 5 times x minus 1. Same thing here. We have 3x squared minus 2x plus 5, or we have 3x squared minus 2x minus 5. So we multiply 3 times negative 5, put that up top, so negative 15. We put this in the bottom, so that's negative 2. I need two numbers that multiply to get each of them. So I get negative 5 and 3. And I put that in, so I get 3x minus 5 and 3x plus 3. Factor out the 3 in here. And I get 3x minus 5 times x plus 1. So finding solutions from factoring. So really this is the way we find roots. So we have x minus 2 and x plus 3 is equal to 0. We set each of these equal to 0. So x minus 2 is equal to 0 and x plus 3 is equal to 0. And then I just solve. So I add 2 to both sides and I get x equals 2. I subtract 3 from both sides and I get x equals negative 3. So those would be my solutions. Now there are different types of solutions. A positive solution is a solution that is greater than 0. So for instance, 2, 4, 9, those would be positive solutions. Negative solutions have a negative value. So negative 2, negative 4, negative 9, those would be negative solutions. And then 0 solutions means that the only solution is exactly 0. Lastly, there are no solutions, which means there are no values that will make this statement true. Okay, so we want to know in these equations what kind of solution we're going to have. So I don't need to know what the solution is, just what kind of solution we're going to have. Well, for this one, I can see that I would divide by 7 on both sides. It doesn't matter what that actually comes out to be. All I need to know is that 5 divided by 7 is going to be positive, so this is a positive solution. Here we have 5 minus 3x is equal to 7. I know I'm going to subtract 5 from both sides. It's going to stay positive because 7 is still bigger than 5, so this is going to stay positive. Then I'm going to divide by a negative, so I know that this is going to be a negative solution. So even without solving, which I did here, even without solving, I can just use logic to figure out that this is going to be negative. Here we have 8x plus 3 and 8x minus 11. Well, I should notice that in order to combine these, I'm going to have to subtract 8x from both sides at some point, and I'm going to get 0. So my x completely drops out. So therefore, this is no solutions. Now here we have 4x equals 0. Well, we know if we divide by 4, 0 divided by anything is going to be 0. So this is just 0 solution. Now types of solution sets. So two real solutions means that there are two answers that can work. One solution means there's only one answer. No solutions means there's none. So here, we need to decide how many solutions we're going to have. Well, this 3 doesn't provide me with a solution. We should notice that we can set this equal to 0 and get x minus 3 is equal to 0 and x plus 2 is equal to 0. Well, that tells us that this is going to be a solution and this is going to be a solution, so there are two real solutions. So even without solving it, I know that there's going to be two real solutions. Now let's look at this one here. X minus 2 and x minus 2 is equal to 0. Well, again, 1, 2 solutions, but notice they're exactly the same. So therefore, we can't count them twice, so there will be only one solution there. Here, we can move everything over, and we should notice that we end up with x plus 2 squared is equal to negative 2. And when we do that, we end up with no real solutions because we can't square anything and end up with a negative value. Okay, reading through the problem. So as you read through the problem, there's a few things you need to look for in any word problem. The first thing is, where are the numbers at? So that's what we need to know. All the rest of it, for the most part, is just fluff. So what are the numbers? What are the units? So are we looking at people? Are we looking at feet? Are we looking at apples? Are we looking at yards or miles or whatever? What is the units that we're looking at? Next thing, what are they looking for us to find? Okay, so what is the unknown that they're trying to get us to get to? And lastly, ignore the rest. The rest of it doesn't matter. It just provides context, but it doesn't provide any information that leads to us solving the equation. So in this one, it says, in order to start constructing the house, Charlie and his father needed to gather some wood from the forest. They initially have 15 extra planks of wood in the house, and Charlie and his father got 10 planks of wood each. How many pieces of wood do they have in total? Well, first step is, what includes numbers? 15 and 10. That's what we know. Okay, that's the important part. 15 and 10. What are the units? Well, they are planks of wood. So we have 15 planks of wood and 10 planks of wood. What are they asking us to find? The total number of planks. Ignore the rest of the information. So notice I crossed everything out. We have 15 planks of wood initially. We have 10 each. And then we want to know the total. That's it. Everything else we can erase. It doesn't really matter. So again, we have our information. We know what they're trying to have us find. So now we're going to pick the correct equation. So total means that we're going to find the sum or addition of everything. So we know we're going to have 15 planks plus 10 planks, and in reality it's 2 times 10 planks because there's 2 of them. And that's equal to X number of planks. That's it. That's as easy as it is. So let's look at one from your actual assignment. It says Ryan is just 4 years older than Blair. The total of their ages is 24. How old is Blair? So again, what includes information? 4 and 24. What are the units? Years and years. What are they asking us to find? Blair's age. So now, again, ignore the rest of the information. We do need to know the names a little bit just so we can keep it straight, but in reality, the names don't matter that much. We want Blair's age, and we know that she's 4 years older than Ryan, and their total is 24. So we write our equation based on the numbers, the units, and what they're asking us for. So we ignore the rest. So picking the correct equation, total equals the sum, right? Where the sum of their ages, or the total of their ages, is 24. And we know that Blair is X years old. We don't know how old she is. We just know that she is some age. We know that Ryan is 4 years older, so it's Blair's age, X, plus 4 years old. And then we can solve that from there. So we would go ahead and add X plus 4 and set that equal to 24 and solve for X, and that would be Blair's age. Now, what is an inequality? An inequality can be of any of these forms. This symbol, this one here. So this one looks like an arrow going this direction, an arrow going this direction. And then we have the arrows with the little bars underneath. And what do these mean? Well, this first symbol means less than. So we have this symbol meaning less than. This one then means greater than. This one means less than again, right? Because that's this arrow. And the bar means or equal to. So this is less than or equal to. And this one, this arrow here, meant greater than. And the bar means or equal to, so it's greater than or equal to. So those are the different inequalities. Now how can we remember the signs? The easiest way I remember the signs is Pac-Man. So we have Pac-Man here. And Pac-Man's rule is Pac-Man always eats the bigger number. So if you notice, Pac-Man's mouth forms that arrow shape that we just talked about. So it forms the symbol. So if Pac-Man is always eating the bigger number, then we can recognize the way that we can state the symbols. For instance, we have 3 and then this symbol and 4. Well, Pac-Man eats the bigger number, so if I draw Pac-Man on there, I can see that his mouth is eating this side here, which means this is the bigger number. So this number is greater. Well, we always read it from left to right though. So that means if this number is greater, this number's got to be smaller. So we would say 3 is less than 4. Now here we have 6 on this side, 2 on this side, and if we draw Pac-Man in, there's Pac-Man. Pac-Man, again, always eats the bigger number. So we have 6 being bigger, and we read it from left to right, so we say 6 is bigger than 2, or 6 is greater than 2. So that's one way we can remember the signs. Now, plotting inequalities on a number line. When plotting inequalities on a number line, you must follow specific rules. First of all, for less than or greater than symbols, we use an open circle. For less than or equal to or greater than or equal to, we use a closed circle. And then we shade in the direction of the inequality. So how do we remember the circles? The way we remember it is this. Every inequality gets a circle. And if they add more to the inequality, we add more to the inequality. What does that mean? Well, this is a basic inequality symbol. This is x is less than 4. Well, this is a basic one, so we start with a circle. If they don't add anything extra, meaning they don't add the bar underneath, then we leave it as it is and leave it as an open circle. Now, if they add something to it, for instance, this one says x is greater than or equal to 2. If they add the bar underneath, so if they add something extra, we add to it as well and shade the circle in. So now we know that if there's no bar, we leave it as an open circle. If there is a bar, if they add something extra, we add something extra also and fill it in. So let's look at how we plot these inequalities on a number line. Well, we have x is greater than -3. So first of all, we're going to find -3, which is here, and we're going to decide what kind of circle we need to use. Well, we start with an open circle, and we decide whether we need to shade it in or not. Well, they didn't add anything extra, no bar, so we don't add anything extra either, and we leave it as an open circle. Then we need to shade the values that for x that apply. Well, it says x is greater than -3. So where are all the x's that are bigger? Well, -2 is bigger than -3, -1 is bigger than -3, 0 is bigger than -3, so it's all the numbers on this side. So we would go ahead and shade it with an arrow going this direction, meaning that all of these numbers over here are bigger than -3. Let's look at another example. We have x is less than or equal to 3. So now we're going to go ahead, we would start with an open circle here at 3. And we decide, did they add anything extra? Well, they added the bar underneath, so we will too, and we will come up with a closed circle. Now from there, we're looking at all the x's smaller than 3, right? Because Pac-Man's eating 3, so that means 3 is bigger than all the x's. Well, where are all the x's smaller than 3? Well, they're smaller on this side here, so we would shade in this direction. Now, what is a compound inequality? A compound inequality is 2 or more inequalities joined together by and or. And what does that look like? It looks like this. 2 is less than or equal to x is less than 6. So that means, what that really means is x is somewhere between 2 and 6. And because it has the or equal to on this side, it can include 2, but it can't include 6. So it's somewhere between them. So how do we do this on the number line? Well, we're going to do the first part. Well, we see that we need to plot a point at -3. So we're going to start with an open circle. And we look at the symbol here. They didn't add anything extra, so we won't either. So we'll leave it at -3. Then we'll go to this one. We know we're going to have an open circle at 4 and check to see if they added anything extra. They didn't add anything extra, so we're going to leave it just like that. And we can see here that x is between those two numbers. So I'm going to shade everything between those two numbers here. And that's my compound inequality on the number line. Let's take a look at another example now. We have -2 is less than or equal to x is less than 5. So we know we're going to have a point at -2, and they did add something extra, so we will too. So it's going to be a closed circle here at -2. And we're going to have a point here at y. They didn't add anything extra, so it's going to be an open circle. And based on our compound inequality, we see that x is between those two numbers, so we're just going to shade in between. Now let's talk about and statements. So and statements imply that both inequalities must be satisfied simultaneously. So for instance, x is greater than 4 and it's less than 6. So we know that tells us it has to be between 4 and 6. So this is an example of an and statement. And statements should always be shaded between the 2 points, just like this. So this is an example of an and statement. Now let's look at or statements. Or statements imply that one or the other inequality must be satisfied, but not necessarily both. So in this case we have x is less than -2 or x is greater than 5. Well, whenever we have an or statement, they should be going in different directions. So we have x is less than 2, which means it can go this direction from -2, or it can go to the right from 5. So that's an or statement. There's a video here that shows you how to check your work when dealing with inequalities on a number line using Symbol Lab. So go ahead and watch that video. Now, most of the time in the past, when you've done systems of equations, you've probably really only looked at it with linear equations. But these can come in any form. We can have a system of any type of equation. So the different types are linear equations, exponential equations, absolute value equations, logarithmic equations, quadratic equations, sine or cosine equations, tangent equations, and trinomial equations. So a linear equation, first of all, looks like this, y equals mx plus b, and it forms a straight line. So it should look something like that. Exponential equations come of the form y equals a times b to the x, and it forms this curved shape like this. Absolute value equations come of the form y equals a times the absolute value of x plus b, and it forms this V shape. Logarithmic equations look like y equals log of a, and it should look like this, some kind of curve like this. Notice the difference between a log equation and an exponential equation is that the asymptote for a log goes vertically, and the asymptote for an exponential function goes horizontally. Quadratic equations. Quadratic equations look like y equals a times x squared plus bx plus c. And when I graph it, it forms a U shape. Sine and cosine come of the form y equals sine x or y equals cosine x. And it forms this oscillating up and down shape. Tangent comes of the form y equals tangent x, and it forms like this snake looking thing here. So it starts like this, curves, and then goes back up. Trinomial equations look like ax cubed plus bx squared plus cx plus d, or it can look like this, y equals x plus a times x plus b times x plus c. And that's going to look like this, where it goes up, changes directions, and comes down. It almost forms like two different parabolas. So that's a trinomial equation. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. So the first one says, consider the equation 3x plus 5 equals 17. If we multiply both sides by 0, will we get the same solutions or not? And in this case, we know that when we multiply both sides by 0, we get 0 equals 0, which then gives us different solutions. So we'd mark that one as different solution. Then if we scroll down, we can see more questions. This one says, James solves the equation x plus 1 times x minus 2 equals 10 by solving the equations x plus 1 equals 10 and x minus 2 equals 10. Is James' calculation correct? Well, we know that it is not correct, so we put James is incorrect. Now we go ahead and scroll down and we keep going until we get to the end. Once you get to the end, go ahead and click next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.